Remember in our previous lesson, I told you you can only add or subtract similar surds. And what are these similar surds? Two or more surds are said to be similar if and only if those rational numbers under the radical sign are exactly the same. So let us start with the first one here. We want to add root 8 and root 18, then subtract root 2. But all of these three surds are not the same physically. We have to transform them into similar surd before we can carry out this simplification. Otherwise, we cannot. So how can we transform them into similar surds? In our previous lesson, we have learned how to convert pure surds into mixed surd. But this root 2, we cannot convert it into anything because the lowest surd we can have under square root is root 2. So how can we transform this into mixed surd? I will only use this first example to show you how to convert them into similar surd step by step, but all other ones I will just go direct. First of all, let us list out all the factors of 8, starting with this 8. We have 1, those numbers that can go into 8 without remainder. 1 can go, 2 can go, 4 can go, and 8 can also go into 8. Then the next one is 18. The factors of 18, we have 1, we have 2, we have 3, we have 6, we have 9, and we have 18. These are the numbers that can go into 8. Likewise, these are also the numbers that can go into 18. Out of these 4 numbers, we want to find out 2 numbers that we can multiply together to get 8. But one of the numbers must be a perfect square number. The only perfect square number here is 4, but 4 times 2 is equal to 8. So therefore, we can write 8 as 4 multiplied by 2. Then coming on here, the only perfect square number here is 9, but 9 times 2 is 18. So we say 18 is equal to 9 multiplied by 2. So we can replace 8 with 4 times 2 and 18 with 9 times 2. So let me repeat the question. We have root 8, then plus root 18, then minus root 2. For 8, we can write it as 4 times 2. So this is equal to 4 multiplied by 2, then plus root 18 is the same thing as 9 times 2, then minus root 2. From the rule, when you have 2 numbers multiplying one another under square root, you can take their square root independently. Square root of 4 is 2, so you can take out that 2 outside. We have 2 root 2. Plus 9 is the perfect square number here, so the square root of 9 is 3. You can bring it out as 3 root 2, and finally we have minus root 2. Now we want to add 2 root 2 plus 3 root 2, making 5 root 2. Let's treat these root 2s as oranges. So first we have 2 oranges plus 3 oranges, making 5 oranges, then subtracting a single orange, making 4 oranges. So this becomes 4 oranges, where root 2 is the orange here. So finally, after simplifying this is what we have, 4 root 2. Let us move on to the next one, which is 2 root 3 plus root 27. We can only break this down, because for 3, you see we have factors of 3 are just 1 and 3, and none of them is a perfect square number, so we have to leave it like that. It cannot be broken down into any smaller piece. So we have 2 root 3 plus. To make this similar to this, we have to think of a number that we can multiply with 3 to get 27. And I believe 9 times 3 will give us 27. So we can write this as 9 multiplied by 3. This is equal to 2 root 3 plus 9 is a perfect square number. The square root of 9 is 3, so we have 3 root 3. And finally, we have 2 bundles of root 3 and 3 bundles of root 3, making 5 bundles of root 3. So after simplifying this, this is what we have. Let us move on to the third problem. So the third problem, we have 3 root 75 minus root 12 plus root 108. I told you subsequently I will not be finding all the factors of those numbers, but it's left for you to find out all those factors, then take the perfect square among them, then multiply with any of those numbers that can give you the number under the square root. I know 25 times 3 will give me 75. 25 is a perfect square number. So this becomes 3. Inside the square root we have 25 multiplied by 3 minus, I know 4 is a perfect square number. When multiplied by 3 it gives 12. So I can write this as 4 multiplied by 3. And finally, I know 36 multiplied by 3 will give me 108. So in each case, you see we have 3, 3, 3. And each of those numbers multiplying 3 are perfect square numbers. So this becomes 3. Already we have 3. But square root of 25 is 5. So we are multiplying this 3 with that 5 that is coming out. But in the square we still have 3. Minus square root of 4 is 2. So 2 is coming out, leaving 3 inside the square root, plus 36 is a perfect square number. Taking the square root of 36, you get 6. Then inside we still have 3. 3 times 5 is 15, so we have 15 root 3 minus 2 root 3 plus 6 root 3. Now finally, we add and subtract to get our final answer. 15 bundles of root 3 minus 2 bundles of root 3, we are getting 13 bundles of that root 3. Then 13 bundles of root 3 plus 6 bundles of root 3, making 19 bundles. So this is equal to 19 root 3 as our final answer. Let us move on to the second to the last one. We have 2 root 8 minus 3 root 32. We have 2 root 8 minus 3 root 32. A perfect square multiplying another number to get 8 is 4 times 2. So we have 4 multiplied by 2 minus 3, and I believe 16 times 2 is 32, and 16 is a perfect square number. This is equal to square root of 4 is 2, so we have 2 multiplying 2 because already we have 2 outside. Then in the radical sign we still have 2 minus 3 multiplying the square root of 16 is 4, multiplying 4 we still have root 2 inside. This is equal to 2 times 2 is 4, so we have 4 root 2. The minus 3 times 4 is 12. We have root 2, 12 root 2. This time around, if you look at this one is the greatest compared to this. They are all similar, but this one is the greatest. Whenever you are subtracting a bigger number from a smaller one, the result must be negative. So this time around, we're going to have 4 bundles of root 2 minus 12 bundles of root 2. We have negative 8 root 2. And this is our final answer. Let us move on to the last one. We have root 50 plus root 63 minus root 32. 50 can be written as 25 times 2, so we have 25 multiplied by 2. But from here you can see this one is an odd number. 2 can never go into 63 without remainder. So we have to think of other way. So this one can never be similar to this. But I know 9 times 7 will give me 63. So I can write this one as 9 times 7. Finally, we have 16 times 2, because 16 times 2 is 32. So you can see this one and this one are similar, but this one is not similar to these two other ones. Square root of 25 is 5, so we have 5 root 2, plus square root of 9 is 3, so we have 3 root 7, minus square root of 16 is 4, we have root 2. These two are similar, so we can bring them together. We have 5 root 2, then minus 4 root 2. Finally, we have plus 3 root 7. 5 bundles of root 2 minus 4 bundles of root 2, we have a single bundle of root 2. Then plus 3 root 7. Because they are not similar, you have to leave them like this. So this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't